All right. So we're talking about linear equations, right? Is what we've been talking about. We're moving into the concept of functions. And that first ed puzzle, I don't know if you guys have had a chance to watch it yet, but we talked about standard form of an equation, and then the slope intercept form of an equation. And then we talked about x and y intercepts and parallel and perpendicular lines. I think the parallel and perpendicular stuff was pretty self-explanatory. X and Y intercepts I'll probably have like a paper assignment for you on that at some point, because they didn't have anything in Delta Math that wasn't like into polynomials, and I didn't want to start there with it. So what your Delta Math assignment is going to focus more on is writing equations in slope intercept form, specifically slope intercept form, because look, I didn't share the screen and I was about to get started on math. Slope intercept form specifically because if something is in slope intercept form, it's so much easier to graph, because it gives you the two things you need, and it's in the title, the slope and the intercept. And so I'm going to do a couple of those problems just so that you can see how they work in both ways, right? Graphing them from an equation and then writing an equation from a graph. So I highly recommend you take notes, but like I said, I'm recording this, so it'll be available to you even if you don't. So we talked about the standard form of a linear equation, which was ax plus by equals c, and a had to be greater than or equal to 1, right? And it had to be a whole number greater than or equal to 1, which is great. It's a great form, but you can't really do much with it. And so the form that we prefer, and you guys all know, anytime I talk about like at the beginning of a year, when I go, does anybody know what the formula for it? Ooh, forgot how to spell intercept. About what they know about writing equations, and they all know y equals mx plus b. They don't necessarily know it's called slope intercept form, but they all can shout out y equals mx plus b. And the reason we call y equals mx plus b slope intercept form is because b is our y-intercept, right? Which means it's a point on that y-axis. And m is a slope. And if I have a point, right, if I have any point, so a y-intercept is a point and a slope, I can make another point. And then I can create a graph of a line, because all you need to graph a line is 2 points. So we're going to do a couple of these, and we're going to graph them, and then we are going to go backwards, and we're going to take a graph and write an equation of a line. So I'm going to start with something already in slope intercept form. All right, I'm going to go, I have y equals 2x plus 2. And this equation gives me two very big pieces of information. It gives me a y-intercept, which is 2, and it gives me a slope, which is also 2. When I think in terms of slope, we talk about rise over run, and if I have a whole number slope, it's always just over 1. We can always think of it in terms of that. I don't like to say rise over run most of the time, because we can also be going down, right? We might not be rising, we might be decreasing. So I like to think of it as up and down, over, side to side. right? Because we don't know if we're going positive or negative. It might not. We don't know which direction we're running, and we don't know whether we're going up or down, but that's what the top is. So when I graph something like this, let's see if I can make a decent graph. Sometimes I find if I do it faster, it's better than if I do it slow. It's not bad. It's not good, but it's not bad either. So to graph it, I'm going to use a different color because I like to see the difference. I don't want it to blend into the graph. So what do we know? We know we have a y-intercept of 2, which means that here on the y-axis, this is my y-axis, this is my x-axis. Here on the y-axis, I am going to have a point at 2. Now my next point's going to be determined by my slope. My slope is positive, so everything's going in the positive direction, or I could take everything in the negative direction, because if I do -2 and -1, it makes a positive, right? 2 negatives make a positive. But let's go up 2, 1, 2, and then over 1. That's my second point. And then I can hopefully pull out my ruler here. Let's see how far I have to go. I'm almost there. And then we can connect the dots. Anytime we have 2 dots on a line, we can draw the graph of the entire line, right? And if I wanted to, I could keep going. I could go up 2 over 1, up 2 over 1. It goes infinitely when we're talking about the graph of a line, right? And that's all I need to do this. Now, if I have a negative slope, say I have y equals -2/3 plus 1, right? We still have all of the right components. We still have a y-intercept, which is 1. And we have, 2/3 x plus 1. And we have a slope, which is -2/3. So when I go to draw the graph of this, ooh, man, that bee is like really lost today. Usually just opening the door and turning off the lights sends it on its merry way, but ooh, look at my little triangle at the top. I wonder if I do that here. No, it didn't work down there. So when I look at this graph, I'm going to plot my y-intercept, right? It's just at 1 on the y-axis. Now, what I really want you to pay attention to is I have a -2/3, right? It doesn't matter whether I take the denominator or the numerator to the negative. What matters is that I only do one or the other. So if I decide to make the 2 negative, I go down 1, 2, and then positive 1, 2, 3. If I decide to make the 2 positive, I go up 1, 2, and then negative 1, 2, 3. Does that make sense? Because that's where people tend to screw up, is with the negative. But remember that if I have a negative over negative, if I take them both negative, that's a positive, right? So then we just get our ruler. You guys can use anything, but on here I have, oof, wow, that got big. I have no choice but to use this ruler that I always screw up and change the size of my screen. It's a loud bee too, just to taunt me. Yeah, I get it every day, but usually I just turn off the lights and it goes away. It goes out the door because it wants to get to the light. It doesn't want to be stuck in here. So does this make sense to you guys? Does everybody kind of get the graphing using slope-intercept form? Yeah. You might not always be given slope-intercept form, but whatever you're given. So if I have, say, minus 5x plus 6y equals negative 12, just write it in slope-intercept form. Solve for y, because that's all you have to do to write something in slope-intercept form is to solve for y. So I'm going to start by adding 5x to both sides, plus 5x. And I get 6y equals 5x minus 12. And then I still have this 6 being multiplied to it. So I'm going to divide both sides by 6. And I wind up with y equals 5 over 6x minus 12 over 6. Oops. What is 12 over 6? What's 12 divided by 6? Thank you. I appreciate that, Star. I thought I was going to have to fail the whole class just for not knowing 12 divided by 6 is 2, or at least not responding. So I wasn't really going to fail the whole class, though. So don't worry. Here's the deal. Now I have it in slope-intercept form, right? If I wanted to graph it, it would be super easy. God, I don't know if I want to graph it, but I'm going to. Right? If I wanted to graph it, I know I'm going to have a point at negative 2 on the y-axis. Right? So I know I'm going to have, let me change the color so it stands out. I know I have a point here at negative 2. Oh, that didn't change at all. There we go. Right? And I know that my slope is 5 over 6, right? So I can go up 1, 2, 3, 4, 5, and over 6, which is going to be all the way back here to the end. Right? And then I can connect those 2 points. I'm not going to bother pulling my ruler out for that. You guys can see it. Let's see if I could actually do it freehand. I probably can't, but so yeah. Pretend that's a straight line between those 2 points, and that's the graph. And so that's all your sample questions regarding this. But I'm going to also show you how to make an equation from a graph. And it's really just doing this whole thing backwards. All right. So I am actually going to bust out my ruler this time simply because I want a little bit of accuracy with my graph because I want some definitive points. Well, slope is always attached to x. It's always the coefficient of x. At least only when it's in that form, though. I mean, if you have it in standard form where we had, up here where it's in standard form, we know the slope isn't negative 5, right? Even though that's what's attached to x. You have to have it in slope-intercept form to know what the slope is. You can't tell from up here, right, by what's attached to x. Okay? That's all right. Really, just think of it, don't think about it in terms of forms. Think of it in terms of solving for y, getting y by itself. So if you isolate the y, then you're going to put it into slope-intercept form. automatically, right? Just make sure that your X value is before your number, right? And it's automatically in that slope intercept form as long as you solve for Y. So, well, sometimes you might, like if you have something attached to that Y, like I did up here, right? On the last problem that I did, I had to divide by 6. Okay. If you come across something at all, like when you're doing something, just let me know because maybe you don't know how to get the words out to figure it out. So if you see one like that, even if you just take a picture and send it to me, then we can. Okay. You're welcome. I wish I could do better. So say I have a graph and I have a point at like here, and let's just draw a line somewhere. Oh, I don't want to make that small. I wanted to make it big. I wanted to. All right, so I got a point. Go away. What I know about this, right, is that I have a point at 3 on that y axis, right? So I know I have a y-intercept of 3. If I want to find out what the slope is, I can find any other definitive point on the graph. So if it could be where it crosses the x, if I was on graph paper, like see how it graphs out here, I could find a point like on the corner. But I'm going to look at this one and I'm going to say this here is a point at 1, 1. I know it's a definitive point at 1, 1, right? So I can find the slope between these 2 points. There's a couple different ways I can do it. Sorry, this is negative 1, 1, right? I can use the slope formula, which will be in your Edpuzzle, but you guys might remember is y2 minus y1 over x2 minus x1. Or I can be really crude and I can just count. I can go, okay, well, my rise, well, this just goes down 2, right? And then over 1. So it goes negative 2 and it goes negative 1, which is the same as saying 2, right? So now I know I have a slope of 2. And if I did it mathematically, it would still work out, right? I would go, let's call this my x1, y1, and this my x2, y2. I should still get the same solution, right? If I go 1 minus 3 over minus 1 minus 0, I would still get minus 2 over minus 1, which is 2. So we know our slope, right? Our slope is just 2 over 1. What, this one? This is just the slope formula. Yeah. Yeah. The intercept we just knew because there's a dot right there on the y-axis, right? So intercept's easy because it's just what's that point on y. And so once I have these two things, I can write the equation of this line. I can go y equals 2x, because that's my slope, plus 3. So you can work it backwards as well, is all I'm trying to say, right? You can go backwards with it. So I just wanted you to have some examples with that because you're going to be doing homework in it, and I focused more on intercepts, I think, in the Edpuzzle. And then when I went to make the Delta Math, I'm like, oh, they don't have any good intercept problems here. So I went with writing the equation from a graph and graphing from an equation, because that's really what the whole thing is about anyways. And then it really helps you lead into the next section, which is going to be writing the equation of a line from 2 points, right? And I give you a nice detailed analysis in that with the Edpuzzle. I'm going to sign off on this video here.